Welcome to part 2 of the 3.4 End Behavior of Rational Functions practice problems. Okay, let's look at problem number 1. The function f of x, 5x plus 2 over x minus 3, that's a rational function, can be written in the form of 5 plus 17 over x minus 3. What is the end behavior? Now, when we say end behavior, you have to long divide to get to the horizontal asymptote. Now, this 5 is our horizontal asymptote, and I'm going to show you by doing the long division. So, if we do x minus 3 into 5x plus 2, what we get out is 5 times x is 5x, 5 times negative 3 is negative 15. Change both signs. We get 17 as our remainder. So that is 5 plus 17 over x minus 3. So horizontal asymptote, long division. Vertical asymptote, set the denominator equal to 0. Now, you can graph these and see what they look like. You will not see the dotted lines on the graph. So the end behavior is y approaches 5. Okay, let's look at problem number 2. Rewrite this function, which means long divided. X plus 2, x squared plus 7x minus 12. We do x squared plus 2x. Change both signs. That's negative. We get 5x minus 12. You do 5, positive 5 plus 5. You get 5x and 10. Change both signs. You get negative 22. This becomes x plus 5 minus 22 over x plus 2. So now, y is a polynomial. This is your polynomial, which is also your horizontal asymptote. So y is going to approach x plus 5. Okay, so match each rational function with its end behavior. So we know for a, let's just start with a, and I'm going to do these on separate pages because I might have to divide. I might have to do some polynomial long division here. So a constant. 3 is a constant because it has no variable. So we know that this one goes to 0. So a goes to 5. Now with b, we have 2x over x minus 1. So if I do x minus 1 into 2x, I had to add a 0 for the constant. I get x times x, no, 2, I'm sorry, not x. X times x is x squared. I had to put a 2. 2 times x is 2x minus 1 is negative 2. Then I change the signs. I get positive 2 as a remainder. So our answer is 2 plus 2 over x minus 1. This part goes to 0. So b goes to 2. Y approaches 2. And you can graph all of these and check, but you will not see the dotted lines on the graph. For number 3, 2x plus 3 divided by x minus 1 gives us 2. 2x minus 2. Change both signs. We get 5. And get 2 plus 5 over x minus 1. So c also approaches 2. The whole answer, the polynomial, becomes your horizontal asymptote. Well, yeah, this is horizontal because the x values are the same. Okay, for d, you get 2x squared plus x plus 3 divided by x minus 1. Same value applies. X, 2x. Makes 2x squared minus 2x. Change both signs. You get 3x plus 3. You get to multiply by 3. You get 3x minus 3. Change both signs. You get 6 as a remainder. So 2x plus 3 plus 6 over x minus 1. But this eventually goes to 0. So your asymptote is 2x plus 3. So D goes with 3. Okay, for E, now this becomes a little, it looks a little tricky, but it's not. So let's think about it. X minus 1 into x cubed. You have no x squared term, you have no x term, and you have no constant. So we just put zeros in for place value. So we know that x squared times x is x cubed. X squared times negative 1 is negative 1x squared. Change both signs. So we get 1x squared, bring down your 0x. This is only for place value. Plus x. X times x is x squared. X times negative 1 is negative 1x. Change both signs. First term drops out. You're left with 1x minus 0 plus 1. The constant's over the constant. We get 1x minus 1. Change both signs. First term drops out. You're left with x squared plus x plus 1 plus 1 is a remainder over x minus 1. And that tells us that E goes to 4. Okay, let the function P be divided. May divides by x plus 5 and gets this. How can we tell by looking at the remainder x plus 5 is a factor? The remainder is 0. Because the remainder is 0, that tells us that x plus 5, the divisor, is a factor of that polynomial because we get a 0 remainder. Okay, let's look at our next problem. We have a polynomial with an x to the 4th, which means I should get 4 factors. So what I'm looking for is where y equals 0. Well, y equals 0, the function equals 0. So I have 1, I have 2, I have 3, and I have 4. So to write these as intercepts so you don't get confused. X equals negative 3, x equals negative 1, x equals 0, because these are your inputs, x equals 1. To change intercepts in the factors, you had to change the sign. So x plus 3, x plus 1, well, that one is just x, and then x minus 1. So this is our function factor because somebody already gave us the zeros. If not, we will have to long divide. All right, this one comes from Unit 3, Lesson 1, which we did not do because I didn't want to get off in the surface area. But there are many cones with a volume of 60 pi cubic inches, all right, where they give us h of r, the height is a function of the radius. The height of a cone is the function of the radius because the volume is fixed. So h of r equals 180 over r squared. All right, what is the height of one of these cones? The radius is 2 inches. All right, so this is easy. We can just put 180 over 2 squared, which is 180 over 4. 18 goes into 4 times. With 20 left, that's 45. What is the height of the cone if the radius is 3 inches? So 180 over 3 squared, which is 180 over 9, and that gives us 20. And then finally, 180 over 6 squared, which gives us 180 over 36, which gives us 5. Okay, let's look at number 7, which actually comes from lesson 1, but we can actually think about this. All right, so we got 20 over r. Sorry about that. We got 20 over r. As r goes to positive, no, as r gets closer to 0, as r goes to 0, s of r goes to positive infinity because the graph looks like this. So as r goes this way to 0, the graph goes up. Now let's do the next one in a different color. So as r goes to positive infinity, s of r goes to 0. So as r goes that way, s of r comes down to 0. And this is the definition of an asymptote: a line, a graph touches or approaches but never touches. Okay, I think we can solve most of these on the same page. Okay, non-x. Non-x is a vertical line. The end of it just gets larger in the positive direction. So, keep forgetting to put my pen on. Sorry about that. That gets larger. 9 over x eventually approaches 0. Okay, so for C, 99x over x. The x's cancel out. Our asymptote is 99. So it goes to 99. Okay, looking at D, because this fraction is simple, we can actually separate this fraction. We know that a constant over x goes to 0, so we're just left with x over x, which comes to 1. So the asymptote approaches 1. Okay, let's look at E now. We can also separate this fraction since it's a simple fraction. Plus 9 over x. This part goes to 0. The x's cancel out. E also goes to 99. So this also goes to 4. Okay, finally, F. F is also a simple fraction that can be separated into 99 over x plus 9x over x. This side goes to 0. If we cross the x's out, we get to 9. So F goes to 3.